It is a beast amongst its peers. The dimensions alone defy logic. 1.3 million pounds of aluminum, advanced composites, and special alloys. Its tail stands 7 stories high. Its 4 engines produce over 300,000 pounds of thrust, equal to 3,500 passenger cars. The Airbus A380 is the biggest passenger plane ever built. But how does this monster get off the ground? The best way to see how things work is to take them apart. This is How Things Work. For over 3 decades, the Boeing 747 was the biggest passenger plane ever built. Dubbed the Queen of the Sky, her dominion remained unchallenged for 35 years. Until now. The Airbus A380 is poised to strip the title from the venerable jumbo jet. If the 747 is queen, the Airbus A380 will soon be crowned king.
The A380 is supersized in every way. Its wing, its fuselage, its passenger carrying capability. But beyond that, it's greener, cleaner, quieter, and smarter than any other commercial airliner ever built.
It took years of success and failure to get here. Thousands of man-hours of engineering were needed to get hundreds of systems and subsystems working together. It was the biggest challenge in aviation engineering since Kitty Hawk, building a giant. Everything about the A380 is massive. That means massive engineering, hidden beneath this shimmering shell. 4 million parts, 1 million fasteners, 300 miles of wiring, and 650 tons of aluminum and composites. Inside, 2 decks run the full length of the plane, giving it twice the real estate of the Boeing. And it can hold a staggering 840 passengers. The plane is so big, it could fit 4 Boeing 737s inside its fuselage. 2 back-to-back, and 2 stacked, with room to spare. To get off the ground, massive soaring wings, the largest ever. At over 260 feet tip to tip, the A380 is almost as wide as a football field is long. Underneath it all, 22 main landing gear disperse its 600-ton bulk and keep it from sinking into the pavement. From nose to tail, the A380 is the most powerful airplane ever built. The 4 engines put out 250,000 horsepower, equal to roughly 70 diesel locomotives. And only an inside view reveals the secret to making a monster fly. At full power, the engines suck in over 5 tons of air every second. Enough to empty Madison Square Garden in less than 30 seconds. The fan pulls air into the engine compressor where it is subjected to a crushing pressure of 50 atmospheres. Enough to squeeze a golf ball to the size of a pea. Fuel is injected where it mixes with the air and is ignited. This explosive process raises temperatures in the engine core to half that of the sun's surface. The exhaust is then blasted out the back at nearly 1,000 miles per hour, creating the needed thrust. Any other engine would leave the future of aviation glued to the deck. Building the biggest plane comes with the biggest problems. In 2006, the A380 project short-circuited. Electrical glitches caused a 9-month delay in production. For the second time in 5 years, the assembly line ground to a halt while engineers tried to solve the problem. And that wasn't all. Several major airports threatened not to support the A380's massive needs. That's because the airplane of the future was bigger than many airports of today.
From an engineering standpoint, there's virtually no limit to how large an aircraft you can build. The challenge in designing an aircraft like the A380 is to design it so that it fits in the existing infrastructure of airports.
The A380 needs to use existing taxiways, terminals, and equipment. Worse yet, bigger planes need longer runways. But most airports have no room to grow. The solution? More lift than any aircraft ever built. To fly, a plane needs lift. Lift is generated as the wind moves rapidly over the wing. It's not about the plane moving forward through the air, but rather about the air moving over the wing. In theory, a plane could come off the ground while not moving forward at all if the wind went over the wings fast enough. And the engines don't rocket the plane off the ground. They push the plane fast enough through the air for the air to generate lift under the wing. As enough wind rushes over the wing, high pressure on the bottom and low pressure on the top literally sucks the wing into the air. The A380's wings create so much lift that they flex 15 feet up at the tips during takeoff. With over 9,000 square feet of area, the A380 has the largest wings ever put on a plane. And once in flight, the landing gear comes up and it's sleek and smooth and ready for a long, efficient flight. Nothing this big should get off the ground. But despite having a 40% higher weight than the 747, the A380 can take off in less distance and at slower speeds. It's a soaring taunt to the laws of gravity. For engineers, it seemed that power and lift would solve the last hurdle, until public opinion threatened the plane once again. The A380 had to meet the most stringent noise standards in the world if it wanted to use London's Heathrow Airport. Once again, engineers constructed the solution.
The A380 is amazingly quiet. In fact, if you're on the ground, it sounds 50% quieter than a 747. And the A380 provides 30% more thrust from its engines.
And those engines burn less fuel than any plane in existence. The A380 uses only 1 gallon of gas per passenger every 80 miles. Per person, it's actually more efficient than most small modern passenger cars. Challenges still loom on the horizon. Airport space restrictions, concerns about passenger loads and safety, even baggage handling problems. But make no mistake, this is the airplane of the future. And now we know that's how it works.